So what our task is to get some equations for how these capacitors combine, what the capacitance of our entire circuit is when we wire these in either parallel or series. We'll start off with parallel because it's so much easier. Right here I have a capacitor, some capacitors wired in parallel, and I'm going to call this capacitor C1, and I'm going to call this capacitor C2. And the question is, what's the capacitance of our entire circuit, not including the battery, when I put these in parallel like this? Well, there's a really easy way to understand this. Right here, these things are wires, these are conductors, so it's just as if these are completely connected. And in fact, I could actually, if I could somehow just take these plates and just move them over so that they're connected with these plates, notice what has happened is it's equivalent to having more area. And if these were the same magnitude capacitors, C1 and C2, if they were equivalent, it would be like having double the area of a plate. And notice here's our flat plate equation here. If we just write our flat plate equation for parallel plates, it is epsilon naught times A over D. It would be equivalent to putting these two capacitors together in this way is electronically equivalent to just making the area of our plates bigger. Doubling the area would double the capacitance. So in fact, putting these in parallel is just equivalent to making one much larger capacitor, which has the area of all the plates combined. And here's what that means. It's just like increasing the area is increasing capacitance. Doubling the area doubles the capacitance. All I'm doing is adding up the capacitances of each individual capacitor. So when capacitors are in parallel, the equivalent capacitance, in other words, I could replace these two capacitors by one capacitor right over here that has just capacitance. This would be C, if this were C1 and C2, this is C equivalent, which I often indicate as CEQ for equivalent. This is the equivalent capacitor that I could replace both of these by, and my circuit would have the same capacitance. So all you got to do is simply add the capacitances, and you've got the total capacitance. Simply C1 plus C2 plus C3. Now you may say, hey, that looks somewhat familiar from last year from honors. It is very familiar to resistors in series, not resistors in parallel. So you got to be careful. These are capacitors in parallel. When you put capacitors in parallel, the capacitances simply add.